Hi everyone. The major advantage of C++ STL is all the containers and all the algorithms provided by the standard template library are generic. Okay, so generic means they can work with different data types. If you want to sort an array of integers, you can use the sort function. But if you want to sort an array of books, then also you can use the same sort function. So the underlying data type does not matter unless you have done the work. Okay, so the only thing that it will need is how do you compare two book objects. Okay, you want to compare two books and you need to define a comparison using a comparator, and that will make the sort function work for a array of books. Okay, so in this video we will discuss about generic programming little bit. So this generic programming can be done at two levels, one on an algorithm level. We will see an example now, and we can also make any container as generic. So we will see this in the vector class. So in the vector section I will show you how you can make any container as a generic container. So let's see one example of algorithm that we are going to make it as generic. Okay, so we will see one example of a search function. Suppose you want to search an element in an array, and you can do it using linear search, I know. So let me show you how you can make a linear search function as a generic function. For example, suppose you have an array and let's say it contains these elements. Okay, and let's say you want to search for an element 10 in this array. You will then make a simple function like this, int search, and you will say okay, you have an array of integers and you have n number of elements in this array, and you want to search for a integer element. Okay, then simply what you can do, you can put a for loop, int position equal to 0, position less than n, position plus plus, and if you see array of p equals to key, you say okay, return this particular position. Otherwise, if the element is not present, you can say return n maybe. So n means this element is not found in the array, and you return the last index of the array. Okay, the index after the last index. Okay, that, and the last index is just n minus 1. Okay, so what we are going to do, we are going to make this function as a generic function. Okay, so let us see first how this search function works. I give this, n is going to be size of a upon size of int. Okay, and I can say okay, I should give n as n, and then I should give the key. Okay, so let's run the code first. So this is nothing but this is linear search. Okay, but suppose you want this linear search to work for all kinds of arrays, then what you should do, then you need to make this function as a generic function. Okay, so we are getting this 10 is at index 4, that's correct. So let's see how we can do it. So the way to do it is using templates. Okay, so you need to say this function is a templated function. It will accept data of type t. Okay, you can say template class t, or you can say template type name t, both are fine. And wherever you are passing this array, you can say this array will be of now type t, and int n number of, this will still remain an integer because a container will have n number of buckets, and the key will now have a data type t. Okay, so this must be there. So you must pass this array as now t, and this must be t. Okay, and rest everything will remain same in this function. Now what I can do, I can call this function for an integer array. I can also call this function for a character array. Let me say let's say I want to make an array of strings. Let's say hash include string. Okay, or let's say just make a array of characters. Okay, so let's say, or let's make an array of floats. Okay, let's say 1.1, 1.2, 1.3, And let's say I want to search for 1.2 in this array. I can just see out search, and what I want to search is in the array B, number of elements is 3, and I want to search for 1.2, let's say, and I will just comment this out. So let's run the code and see the output now. Okay, so let me say float k equal to 1.2. By default this is being treated as double, so let's say this is k now and see the result. So we are getting 1.2 is at index 1. So now you can see we had a simple linear search function and we converted it into a generic function that works with all types of objects. And you can also call this function with different type of data. Maybe you want to search in an array of books, you want to search in an array of persons, you want to search in an array of characters, and this is going to work this way. Okay, so I hope you got a basic idea of how to make a function as a generic function, and the same will be applicable for data structures also. Okay, so I will show you one example in the vector section where we will implement a container and we will make it generic. So that's all for this video. Thanks a lot.